Hello everyone, this is Vani from R.M.K College of Engineering and Technology. So in this unit, we are going to concentrate about to define electric field intensity, to solve problem based on electric field intensity, to define and understand the significance of principle of superposition. So let us consider one charge, say Q1, fixed in position in space. Now imagine that we can introduce a second charge Qt as a unit test charge that we can move around. So we know that there exists everywhere a force on this second charge Qt. This second charge is displaying the existence of a force field. And this force field is given by Coulomb's law, which is Ft, that is force on test charge Q, is equal to 1 by 4 pi epsilon naught Q1 Qt into the unit vector divided by R1t square. So writing this force as a force per unit charge gives force per unit charge gives 1 by 4 pi epsilon naught Q1 by R1t square A1t. This vector field is termed as electric field intensity. Electric field intensity, the physical significance is it shows the strength of electric field. So we define the electric field intensity as the vector of force on a unit positive test charge. So electric field intensity E is measured by unit newtons per coulomb or volts per meter. So E is nothing but Ft by Qt and given by the expression 1 by 4 pi epsilon naught Q1 by R1t square A1t. The field of single point charge can be written as 1 by 4 pi epsilon Q by R square AR bar. If we consider only single point charge, then this Q1 is represented by Q, R1t is represented by R, and A1t is represented by AR for single point charge. Where AR is the unit vector in the direction from the point at which the point charge Q is located to the point at which E is desired or measured. So, for a charge which is not at the origin of the coordinate, the electric field intensity, in order to calculate the electric field intensity, we need to consider two distances. One is R, that is from origin to point P, and the coordinates of P are x, y, z. And another point Q, which is a distance R dash from origin, and the coordinates of Q are given by x dash, y dash, and z dash. So, as we want to find out the electric field intensity, the expression becomes 1 by 4 pi epsilon naught Q by R minus R dash the whole square into, we need to consider the distance R minus R dash and divided by magnitude of it. So in this case, when the charge is not at the origin, the expression becomes 1 by 4 pi epsilon naught Q into R minus R dash divided by R minus R dash the whole cube. Magnitude of R minus R dash the whole cube. Now, what is meant by R minus R dash? Actually, we are finding out the distance between point P and Q. So it is represented as x minus x dash AX bar, y minus y dash AY bar, z minus z dash AZ bar. And the denominator, we are calculating the value. So as it is square root of the x minus x dash square plus y minus y dash square plus z minus z dash square, the expression termed as 3 by 2. So the electric field intensity due to more charges, suppose we are assuming 2 or more charges, say Q1 at R1. We are taking at distance R1, Q1 is the charge, at distance R2, Q2 is the charge. Then the sum of electric field intensity Qt caused by Q1 and Q2 acting alone is given by the total electric field intensity 1 by 4 pi epsilon naught Q R minus R1 the whole square A1 bar plus 1 by 4 pi epsilon naught Q divided by R minus R2 the whole square A2. The meaning is that the total electric field intensity is the summation of two electric field intensity resulted due to Q1 and Q2. That principle is called as superposition principle. Now let us define superposition principle. It states that every charge in space creates an electric field at point independent of the presence of other charges in that medium. So the resultant electric field is a vector sum of the electric field due to individual charges. So the superposition principle is used to compute the net field, net potential energy of the system. The superposition principle is helpful even when there are large number of charges in a system. So let us consider one positive charge and two negative charges exerting a force on it. From the superposition theorem, we know that the resultant force is the vector sum of all the forces acting on the body. So this is the direction of resultant force. So if we mathematically represent superposition principle for this example, it is represented as the total force Fr is equal to 1 by 4 pi epsilon capital Q into Q1 divided by R12 square into R12 cap, that is the unit vector, plus capital Q2 divided by R square 13 and unit vector along the direction 13. So it is a summation of both the forces where R12 and R13 are the unit vectors along the direction Q1 and Q2. Epsilon is the permittivity constant. Capital Q and small q1, q2 are the magnitude of charges respectively. R12 and R13 are the distances between the charges Q and Q1. Similarly, Q and Q2 respectively. So this simple example shows how superposition principle is applicable to find the total force when many charges are acting in the field. So let us understand electric field intensity calculations through an example. So in this example, a charge Q1 of 2 microcoulomb is located at P1 0, 0, and second charge of 3 microcoulomb is located at P2 minus 1, 2, 3. We have to find E, that is electric field intensity, at M 3, minus 4, 2. So as we know the equation for electric field intensity, this is the case of superposition. Two charges are acting. So we know the expression as 1 by 4 pi epsilon naught Q1 by R minus R1 square A1 bar plus 1 by 4 pi epsilon naught Q2 by R minus R2 the whole square A2 bar. So we need to find out R minus R1 and R minus R2. So what is R, what is R1, what is R2 in this expression? We are finding the electric field intensity at M of 3, minus 4, 2. So this is R, right? And point 1 P1 is R1, point 2 P2 is R2. So if we find the distance R minus R1, subtracting this 2, it becomes as it is 0, 0, 0. This expression remains 3ax bar minus 4ay bar plus 2az bar. If we calculate R minus R2 bar, it is the subtraction between these two, the distance between these 2 points. So it is given by 3 minus of minus 1 is 4ax bar, minus 4 of minus 2 is minus 6ay bar, and 2 minus 3, that is minus az bar. If we calculate the magnitude of this, it becomes 29, and magnitude of this is square root of 53. So if you substitute the values into the expression, actually we can calculate A1 bar by using R minus R1 divided by R minus R1 magnitude. But when we substitute this value, this expression can be simplified like this. It's just mathematical substitution only. So if we substitute all the values which we have calculated here, and then substitute the value of epsilon naught also 8.854 into 10 power minus 12, then we are able to find out the total electric field intensity as this, whose unit is volt per meter. So by this we have understood how to calculate electric field intensity by using superposition principle where more than one charge is acting in the field. So as a summary, we have defined what is electric field intensity. We have solved a problem based on electric field intensity. We have also understood the significance of principle of superposition theorem when more charges are acting in the field. Thank you.